Good morning and afternoon, everyone. Welcome to our Fast Track Friday Hangout. I'm Wayne Griffenberg. I'm an applications engineer for Autodesk, and I work with the CAM team and the Fusion teams. And we bring these Fast Tracks to you each week. We do our Wednesday webinars as well as our Friday, more advanced webinars. Today we're going to talk about our mesh to machine. We're going to download and upload an STL file into Fusion, and we're going to use it to be able to get our CAM programmed on the part to be able to get the code out to the machine that we're looking for. We're also going to do a little bit more involved setup in there as well. So before we get started, I just want to ask a couple questions of you guys. I do appreciate, I see a lot of names that come in each week, but a few new people, and we'd like to learn a little bit more as we're going through and we do these webinars to ask a few poll questions of you just to get your feedback on how we're doing and what you're looking for in our interfaces. So we'd like to know what's going to help drive your growth. So if you could take a minute and please answer a poll question for us to let us know what you're doing today. If you're machining, if you're doing 2 to 3 axis machining, in the future you're doing more mill turn, maybe you're going to buy a mill turn machine, a Haas TL machine or ST machine, you're going to do some live tooling in the future. Maybe you're going to do some more multi-axis stuff with a UMC or a Mitsura machine, and you want to see more development or more information or more content on the web on how to use Fusion or how to use our CAM to drive those machines. So let us know what's going to help drive your growth, because it's going to help us add content to our YouTube channel as well as our training sources, and our developers will get this feedback as well to know where to focus to help you guys out. So looks like the majority of you have voted. I really appreciate that. I'm going to close out the votes, and let me share those with you guys real quick. So it looks like we have a pretty close to even split with the voters this week. We do have people who are looking an even amount who know that working with 2-axis and 3-axis milling as well as turning and mill turn are going to help the future to drive their business. And it looks like we do have a good percentage of people who are looking more into water jet, laser, and plasma torch. So it looks like it's a pretty even flow across the board. Again, we really appreciate this feedback, and it helps us grow our great product as well as all of our online resources to help you guys. So I'm going to hide that real quick. Another quick question for you. Have you guys ever been to Autodesk University? I want to let you know this year it's very CAM focused, although it was last year, but this year we do have, we believe 9 full classes going from intermediate to advanced this year that you guys can join. So if you check out Autodesk University online, I highly recommend you register. There's going to be hands-on classes to teach you a lot of those the skills that you would need to use our interface to get the code and your CAD and your CAM integration to be able to run on your machines. Hands-on training, as well as working in keynote speakers, as you'll get to meet a lot of our elite users and developers as well.
Yeah, I mean, those 9 classes is taught by some of the experts like Seth, who joins the call regularly, Rob Lockwood, Lawrence, some of our top users. In addition to those 9 classes, there's going to be 2 dedicated days. One to go through the complete process of developing and manufacturing a product, and another dedicated day to sort of do a deep dive into CAM for people that are new to machining. So AU is shaping up to be pretty exciting.
Yeah, that's going to be awesome, Al. And if you recognize some of those names, and if you go into our forums, you'll see them, you'll see Seth and Lawrence and Rob are very active in our forums and helping people every day, getting back to them, walking through some setups with them to be able to help them get their parts made and answer questions. So they're going to be driving some of those classes this year at AU, so it's definitely something that would be great for you guys to join. So I'm going to close out of this poll. Again, we really appreciate you guys voting for us. I'm going to share it real quick. It looks like we have a good amount of our audience who will be making some chips. They're not going to be able to make it out to Vegas this year. And that's good. They'll be making some parts, making some money. That's okay. A good 30% of you would love to want to be able to get out to Autodesk University. We can definitely get more information out to you following the webinar. And so it looks like we have about 15% who have already been to Autodesk University and really enjoyed it. So we really appreciate that feedback. So let me close out. I'm going to hide out of this. And so let's jump right in. So I'm going to start to talk about today. Let me bring up this other slide. So today's topic is on meshes and working with them to get our toolpaths on them and out to the machine, and basically how to work with STL files. So I'm going to download a part and import an STL file into Fusion. I'll show you how to modify it, some basic modifications we can make to the STL file. I'm going to show you how to use that STL to do setup in CAM and be able to orient it, get it ready for machining. Apply some 3D toolpaths to those STL models. Simulate, and at the end we're going to save the result of the STL file to create a new STL file that we're going to use to bring back in to be our Op2 setup. We're also going to use STL file, or I'm going to walk through with you some resources that you can learn on how to bring that, work with the meshes, to be able to use the sculpting tools and make solids from those files. So I have a couple slides just to kind of go through to give you a visual of what we're going to do. We're going to import a part like this. This is actually a reversing switch for a Harley-Davidson buggy. I didn't know they made them, but I was working with a customer following up from a previous webinar who wanted to be able to was working on for a customer making a restoring one of those old Harley-Davidson buggies, and he needed this switch to be able to do it. And so as we're walking through, I was kind of helping them. Who knew that Harley-Davidson made buggies like this? But back in the day, they did. And one customer was restoring one of these. And there's a switch in here that he was trying to get. He wanted to machine it. He's got a small Haas machine, and he wanted to machine it out of Delrin real quick to be able to get the part inside that switch. So we did a quick search inside of, let me grab it here like this. We did a search in GrabCAD. So I'm going to go over to GrabCAD real quick. I think I had it up earlier. That's okay. GrabCAD, and I did a quick search for that switch for the Harley-Davidson buggy, and we found one. Thanks, Keith, for uploading this part for us to be able to use. And it's an STL file, so we're going to work with that part. So I'm going to download it. You click in here, get a view of the part. I can download the files. The part we're looking for is this inner contact support STL file. So we're going to download that file. It's going to save to my downloads folder, so I'm going to go into and show that part in the folder. So really quick, I did a search for the part. I was able to find it. I can see that part, confirmed it with the customer that that's what he's looking for to make. It's an STL, so we download it, so we don't have to redesign that part. It's already up there because somebody contributed, designed it, and contributed it into GrabCAD for us to be able to work with. So I'm going to bring this inner contact support into Fusion. So let me bring up my Fusion real quick. So I know it was mid last year, our team was starting to work with tools to be able to work with our mesh and our STL files to be able to bring them in. So this is a quick and easy way to do it. I'm not the go-all guy for all the STL files, but I'm able to work through it. I was able to help a customer, and I think it's pretty awesome the way that Fusion handles and is able to work with those files. And I'd like to walk through with you what we did. So I'm going to go up to Insert. I'm going to insert a mesh, and this is one way you can do it. I'm going to go to my downloads, and I downloaded that inner contact support. So this came right from GrabCAD. I'm going to go to Open. Now as soon as I open it, it looks like it was a normal file, like a normal Fusion file or an uploaded solid file that you'd normally work with, and insert it inside of Fusion. We have our handles. We're able to move this part around if we need to. I can compare it to the origin. I can move it. I can also rotate the part, so you have full access to be able to get it in position that you need inside of Fusion. So if I mess up, I can always go back and reset and put the part right back where it was. So you do have that same capability to manipulate and move around the file as soon as you bring it in. So that's where I want it, sitting right there off the origin. I'm going to say OK. So you see this STL file. We have a good number of facets. You've probably seen STLs. You've seen them kind of go off the triangles, go through and do radiant off of one arc to another, things like this. We're going to try to modify this because I don't really need the holes in there. So we're going to modify it right here at the STL level. But we also have a lot of facets in there. So I'm going to take a look. If I expand down bodies, you see now we have the mesh body in our browser as well as in our timeline. If I right-click on that mesh body, we have a few functions we can do. We can edit. It doesn't really let us create a component yet because it's not a true body. But we can edit the mesh. We can look at properties. We can also change the opacity of the part. I'm going to right-click on, I'm going to click on properties, and I can see how many facets we have, how many of those triangles that make up this mesh body. So it's a pretty good number of facets, but I don't really see that being a problem with Fusion being able to handle that. But in some cases, later on, you're going to find that if you want to translate this later into a solid or you want to do some more manipulation with it, that may be a large number of facets to work with. So we might want to simplify this model a little bit. So I'm going to modify that model. I'm going to edit it to be able to remove those holes. So I'm going to right-click and edit, and it brings me into this mesh workspace. So we have our ability to create a new mesh if we want to insert a mesh, or we can do a B-rep to a mesh. We're able to modify. So we're going to look at some of these tools. I'm going to kind of go through a little bit and overview quickly with you. There are other resources we're going to talk about later where you can get a more deeper dive into what these functions do. But just to give you an idea, to remesh, if I hover over, if I go over to this remesh, the remesh gives you the ability to change the number of facets and also change the mesh that it's more of a linear mesh than these triangular facets that go along from arc to arc. You can also reduce, so I'm going to click here, you can also reduce the number of facets you have in here. So you have the ability to reduce the facets if I select the body. I can also select faces like this, but I'd rather select the entire body. So if I select the body right out of the browser, I can get a preview. So if I want to change the density or if I want it to be adaptive, adaptive means it's going to recognize the features like you see here. Those the facets will array out of a center hole or center position of an arc. You can also change that to uniform, so it's more of a uniform density across the board. So if I get a preview, and I'll select, it'll take a few seconds, but I can preview where we're going to change the density of those arcs and we can make it more simplified. I just want to give you an overview of what this will do to simplify your models, but be careful, in other places you're going to lose some of that those sharp edges. You're going to lose some of that definition by doing that. But this is what
just jump in just for a second here, Wayne. I know there's a lot of people that are new to the webinar. If you're new on your webinar panel, there is a question pane, and if you've got any questions for Wayne while he's going along, what you're covering is perfect, Wayne, but I just want to make sure everybody knows that if you've got something you want them to spend a little more time on or a question, feel free to type that in the question pane.
Oh, thanks, Al. I do appreciate it. Guys, anytime you guys have a question, please do. Feel free to ask. We have a lot of our Autodesk mentors on here with us as well, and they can also check some questions and answer online with you. But please feel free. If there's any questions what I'm going through, if I don't have an answer, we'll be able to get an answer for you quickly. So I'm not going to make any changes. I'm not going to reduce it here. But what I want to do is I want to make changes to these holes here. And notice as I'm hovering over these different areas, I have a selection mode. And I can change, and I can expand this down. I have different ways to select the facets. I can also use a mesh palette. Let me bring this over a little bit, where I can fine-tune what that brush looks like, how many of those facets I grab at any time. While I'm in this hole feature down here, it's not really a hole. It's more of like what would be a hole before it was made into an STL. As I drag my cursor through, I can select those facets, and I can also select it on another hole here as well, like this. I'm just going to drag through until it looks like my paintbrush is all the way in that hole. And I can select that hole too. So it just gives me the ability to change the facets, the number of those facets that I'm grabbing. So I want to grab those two holes and I want to delete them. So I'm going to go up to Modify, and I'm going to go to Delete Faces. And I delete those faces out. It says there's two mesh faces selected. I select them, and if I hover around, you can actually see inside of the mesh body. It looks like I missed a couple chunks there, as well as in here. I think this one looks like I caught most of them. But I want to go in and I want to grab those extra chunks. What I would do is I would change my brush size so I'm not grabbing so many of those facets. And I could just grab them like this and go up and modify and delete those faces as well. So my main purpose here is to be able to delete out those holes because we don't really need them, and I might as well do them at this stage instead of later on avoiding them or add surfaces to meshes, because it's really hard to do that to a STL body. But I want to show you that's the ability. We have that ability to be able to delete faces or change facets that way. Now what I'd like to do is I want to close this mesh body and I want to make it more uniform, that when we go in and bring it in, it's more defined and I have a more uniform set of facets on here. So I'm going to go into Modify, and I'm going to say Make a Closed Mesh. By selecting Make a Closed Mesh, it'll make a watertight solid mesh. It's also going to let me refine that mesh, that I can make it more of an accurate mesh. I'm going to select my body actually out of here. It's also going to select the inside facets. It's going to do it without the holes, and I can also get a preview. It'll take a second or so, about 10 seconds, and I get a good preview of what it's going to look like when I get more of an accurate set of facets in here, as well as being able to make it watertight, so it's going to recognize the places where I have those holes and fill them in as the mesh goes over top of them. You see I have a more defined mesh. Later on, this is going to make it easier if you're going to make B-rep, where you're going to make a P-spline out of this. So you have more of a defined, but be careful too, because you might lose some of that definition here in the corners. So you could change, how fine you want to make that mesh, but keep in mind, the more fine you make it, the more facet you have, the more it's going to be involved to be able to change that body. But for our purposes, this is going to do perfectly. To be able to make this part really quick on the machine and be able to get that part on that buggy that's perfect for us. So I'm going to accept that. So I'm going to hit the escape here real quick. Oops, I didn't hit except for that one. That's okay. So I'm going to go up and select my mesh body, go back down and do it again. I'm going to make a closed mesh. Right there, it's fine. That accuracy is okay with that density. I say okay. That's going to calculate. Usually, again, it'll take about 10 seconds. And then it's going to change this STL body to have a more uniform mesh, as well as make it watertight. So then when I go and put on the Toolpaths later, it's going to recognize that body much more closely. All right, so that looks pretty good to me. It made a new mesh body down here. I still have my original if I want to go back and make changes and work with it, and I can always compare the two. So it makes it easy to compare what we have and what we had before. I can always go back and make changes. I can always define it a little bit better if we want to get a better finish on it. Okay, but keep in mind, we're going to be working with, it's a STL mesh body. We're going to get whatever quality we can in that mesh body itself. Okay, so that looks pretty good. I'm going to finish the mesh. And now I'm back into my model workspace. We have a more defined mesh. We have it without those holes in it. So now I'm ready to be able to machine this. So I want to put some Toolpaths on it to get the code out to the machine really quickly to be able to make this part for the buggy. So I'm going to switch over now over to our CAM workspace. And in our CAM workspace, as you're working with CAM, you can see it's the easy-to-use workspace, being able to set up all your toolpaths and working with your setup itself. Now, one of the things that we got a lot of questions on is when you have an STL model here, and our customers will often go in to do setup, and when you're working with a regular Fusion model, when you click Setup, it generally recognizes the model and it gives you a preview of the stock. So it looks like something went wrong here. So it looks like I'm missing the preview of the stock. The only thing is it didn't recognize it as a model because it's an STL model. It's not really a true body, right? It's still that mesh, but we have surfaces and faces along that mesh that we can use to drive our toolpath, but it doesn't recognize it. So what I want to do is I want to tell it, instead of nothing here, I want to go and pull down these bodies and select Mesh Body 2. And now it recognizes it, knows the boundary of the part, it knows the boundary of all the faces, and now I'm able to set it up and get it into the machine and ready to go. Okay, so now I want to go into my stock tab. I'm going to change this instead of a relative size box, we're going to use a fixed size cylinder. It recognizes the center. I can always tell it what axes, but the thing is you can't grab any axes or any faces off the model because it's not truly a solid. It's still a mesh body, but you can always use the origin. Like if I wanted to flip this axis along the X, you can do it by grabbing the origin there or grabbing the actual x-axis. You can also grab the y, of course. In this case, I'm going to grab the z just to make sure I'm in the right axes in case something changes later on. Now I want to give it the real stock diameter. I'm going with 3 1/4 bar stock, and I want to use at least 3/4 of that stock that's going to be sitting in my fixture down here. And I want to make sure I leave at least 100 thousandths off the top of the part. So I'm going to offset from front, leave 100 thousandths on top to trim off. And that's pretty much set up the way I have it in the machine. So I'm able to use a mesh body to drive the stock and do the setup of my stock. You can still do things like box point to be able to set your points on your box. You can also do model box point. It'll recognize all those as well. And of course, you can set your z-axis along any axes along here, or surfaces or faces that you create. Okay, so I'm going to close out. I'm ready to start machining this part. So the first thing I want to do is I want to face off the top, and I'm going to use our neat trick that we've learned. I think CJ started working with this before, and I really it was really fun to watch him work with it. So I'm going to use that same technique. So I'm going to go to 3D adaptive clearing, okay, and I'm going to go to use a face operation for this one. Yeah, it's interesting. Should normally see the stock there, but that's okay. So I'm going to do a 3D adaptive in this setup. So I'm going to choose a tool. I'm going to select, oh, there's my library. Okay, I'm going to select the face mill out of my library. I'm going to turn it on to make sure I have the face mill showing. And I'm going to use it in the Haas VF2. So I'm going to jump down to the Haas VF2, and I'm going to choose that 1-inch face mill for this part. I can see it in this view. And the next thing I want to do is, my geometry is okay. It recognizes the stock boundary. My heights, what I want to do is I don't want to machine, of course, a face down to the bottom of the part. I want to go from stock top down to model top. That's the area we want to machine out using the face mill. And then in here, I'm going to leave the maximum roughing step down to 50 thousandths. And stock to leave, I'm going to turn off so we can face it down to the top of the part. I'm going to say OK, calculates, and now we have that face toolpath. So again, we're using an STL model to be able to drive a toolpath, face toolpath. So I'm going to adapt it, or adaptive toolpath. So I'm going to show you real quick. We're going to simulate what that looks like as it works its way from the outside in. And I know our elite guys at Pier 9 have perfected this method on being able to make a nice finish on top of the part there.
Yeah, I'm glad you brought that up. So even though this is a mesh webinar, this applies to any type of body you're machining, the use of an adaptive toolpath for facing the top of the part.
Right. It doesn't have to be just a mesh. Exactly. As Al had mentioned, you can do this on any part that you work with. Okay, there's the adaptive. I'm going to close that out. So as the part changes, so will the adaptive toolpath, and it works also with the 2D face. This is just another alternative to be able to get a nice quick toolpath on there. All right, so I'm going to use an adaptive to clear out these pockets in here as well as the outside of the part. So I'm going to go up to 3D adaptive clearing. I'm going to use a 1/4 inch, my bull nose, 1/4 inch, to rough it out. Okay, so for my geometry, now I'm not going to make any changes here. It recognizes the stock contours, but keep in mind, if you try to have any machining boundaries off an STL, it's not going to recognize any selections off the body. That's one thing to keep in mind, that you can't really locate it to specific places unless you make a sketch in a plane to do that. But what's one of the great things about our 3D toolpaths is that you don't have to do that. You can just select a tool. It's going to look at the model. It's going to respect that model. Even an STL model, it's going to drive the tool exactly where we want it to go. So for my heights, I want to cut halfway down, so I'm going to add off the model bottom here 1/8 of an inch. Because I want to flip it over later, and I want to clean up these holes from the other side. And I just want to show you that you can do this. So I'm going to machine down 1/8, or I'm going to keep 1/8 of an inch from the bottom of the model. And then for my passes, I'm going to leave these, I'm going to leave them out of the box the way I have them. I'm going to say OK. It recognizes, even on the STL model, exactly where to drive the tool to remove the chips most efficiently. Really nice adaptive clearing. Tapering down, keeping that same chip load the entire time. Really efficient. You can run at higher speeds, and speeds a really good algorithm, really good toolpath to be able to run. So let's take a look. So I'm going to go up to Setup, and I want to simulate what's going on there. So I'm going to go to Simulate. We've already seen it do the first adaptive for the face. So I just select it out of my browser, and I'm going to play from there, maybe speed it up a little bit, and you can see as it works its way in, cutting out that shape that we're looking for. And again, this is being driven off that STL model. We don't have to create any additional surfaces, faces, edges. It drives right from that model that we generated, that we downloaded, and we changed a little bit just to make it a little bit more fine, and we got rid of those holes. It's looking pretty good as a rough. Okay, so now I want to clean it up a little bit. I'm going to use the same tool. I'm going to use a horizontal to get all the flats in here real quick. So I'm going to go up to do a 3D horizontal toolpath. I'm going to use that same 1/4 inch tool. Go down to my Haas VF. Use that same 1/4 inch bullnose, and we're going to get all the flats inside of the pockets there. So one thing about the horizontal, it finds its own containment, so it knows exactly where to go. It looks at all those flat areas. But one thing I want to change are my heights. No, actually, I want to leave that because I have it set here as a default to stay below the top because we've already faced that off. So I have it set as a default for my horizontal. You can always set a value, right-click, and say Make Default. So when you bring in that toolpath, it knows to stay at least a thou below the top of the model. That's what I did here, just as a trick to keep that horizontal inside of the body there. Not always, but it's going to work in this case. So I'm going to say OK. The horizontal takes a look. It might take a little bit longer to calculate only because it's looking at all the facets where they're flat versus any facets where they're in the corner here sloping. So let's let that calculate. In the meantime, I also want to get a 3D contour to clean up the walls in the part. So we'll use the same tool. I think I have a good radius in here to keep it in those corners. I can also call up a finishing bullnose to finish in the corners as well, or around the walls. So I'm going to select, actually my geometry has an offset. I want to make sure my contour also has a offset as well, as the same as the adaptive. For my passes, I'm going to say my maximum step down, we'll leave that the way it is. We'll go 100 thousandths, looks pretty good. I'm not leaving any stock. I'm going to say OK. And so since the horizontal finished, it found all those horizontal faces. The contour is done, and now it's going to contour. I probably want to get this kind of fine. I can use this tool to make that really fine step down to get those edges there. So this way we're going to rough it out, get it on the machine, and we'll be able to get a pretty good output there. So I'm going to change this passes to, let's say, we'll go 10 thou. Okay, so we'll get a nice little finish. We'll get those little rounds on there on the top as it goes around the edge. So that looks pretty good. So I'm going to simulate this real quick. You go up to Setup, Simulate. Okay, we've already seen it do the adaptive. We're going to look at it through the horizontal and the contour at the end. We can actually play through the contour. I can speed it up, and as we speed up, we can see the other info as it's going and finishing up the outside of that part with the edges on it as well. So again, we're driving these toolpaths off of an STL model. We didn't have to create or even convert it to a solid. You can get your parts right off that STL model. You can get the code over to the machine, and you're going to have a pretty good, decent part. Now, of course, if you're trying to really drive it on the surface, you're trying to stay very precise. Of course, your model has to be precise to keep that precision in the part itself. But if you're not looking for that precision in this case, we're okay driving that off the STL model. So that's the result.
Maybe we should be in the vein of full transparency, with the exception of the facing toolpath. There is a reason Wayne is using the 3D toolpaths. The 2D toolpaths require chain selections, don't really work on STL files. So I just want to make sure we're transparent about that.
Yeah. This is Mike Matera. If I could chime in for a minute. I thought I'd talk a little bit about file types. I hate to interrupt your presentation because it's going really good. You're doing a great job, Wayne. But,
sure, yeah, no worries.
Whenever you're going to get a file, you always want to get things as close as you can to the native Now, us being able to machine an STL is a pretty significant thing because of the way an STL works. Wayne has been referring to the facets, and that's really how you have to look at an STL. Think of it if you wanted to machine a diamond. A diamond is made up of a bunch of facets. Diamonds are never round. They always have facets on them. And the fancier diamonds have more facets. So when you're importing that into a CAD environment, you have thousands and thousands of little triangles, as opposed to when you bring in a solid model, you really have one object when you bring in a solid model. So it's pretty significant that we can machine all these little facets so quickly just by doing a couple of things to manipulate the data that came in. But I just want to mention that because it's always good if you can get the information as close as you can to an original source. So if it's a choice of a SolidWorks file or an STL file, you should always get the SolidWorks file because, as Al mentioned, if you want to do any 2D machining, it's nice to have the edges from the model. So I just wanted to point that out.
It's a great point. I remember early on, in the early days of solid modeling, people would constantly say, well, can you machine a DXF file? When you really prod a little bit, you'd find that, well, a DXF file was generated as an output from Inventor or SolidWorks or Pro-E, and you should just have gotten the solid initially, or at least a neutral solid like a parasolid. Think of it like it's much better to spend time with a friend than just look at a picture of the friend. And to some degree, an STL file is just a picture of the solid. It's not really the true solid. So we can work on it, but if you can get the native, it's much, much better. Sorry for the interruptions, Wayne, but yeah, I think that was a great tangent to take us on, Mike.
Oh, don't be sorry at all. I appreciate that, guys. Thanks, Mike. Thanks, Al. And it's totally true. Whenever you can get the source, like one of the great things about Fusion is that we can upload native files. We can upload SolidWorks files, Pro-E, Creo tools. We can get the CATIA files and upload those native files right into Fusion, have them convert, and you have that solid. And as Mike and Al had mentioned, once you have that solid data, you can always take any edges, faces, surfaces, and you can drive your 2D toolpaths right off of those edges that you get off the model itself. These are important points, but it's definitely good to know that the better quality output you're going to get depends on how good the quality input you have. So in this case, the STL. Yeah.
I was just saying, Aaron brought up a good point. He's working with scan data, and scan data very typically is going to be an STL or a triangulated model. So it's a great application for using this. What Wayne is going through is working with scan data.
Absolutely. Yep. You can scan models, and they're not going to be perfect. There's oftentimes you'll see a lot of those facets will be very bumpy and very hills and valleys and nooks and crannies, but you can use these tools to really define it and really refine it. And there are other tools which we probably won't dive into at this level on this webinar, but there are other tools that you can convert those STLs, especially if you scan them and bring them in. You can convert them to solids and even bring them in as piece splines where you can flatten them out. You can get a nice even face. But those tools, at the end, we'll give you more links and more places where you can find that information. But these are definitely valid points to keep in mind, especially when you're trying to make parts and get them on your machine and then have them be useful. That, again, refined data as you have in the beginning is going to give you a better toolpath at the end. Okay, so as we're here, another step I'd like to show you is this looks pretty good. So I was able to get this simulation done. I can see it's going to work for me. That's what they're going to get on the results of this first operation. What I want to do is I'm going to flip the part over to do the other side. I'd like to use this result as the stock going into the other side of the part as op2. So we do have this option where we can right-click at the result of the simulation, right-click on the body, and you can go down to stock and save stock. And again, we're able to make an STL. I'll save this on my desktop. I'm going to call it my my contact switch. Nope. And I'm going to call it contact switch stock. I'm going to save it right on my desktop. So I'm able to take that result of what we did with the toolpath, and I'm going to bring it back in to my model workspace. Now, you can use that stock to compare when you're in our simulation. I'll show you that later, but I want to bring it in to use that same model as the stock for the next operation. So I'm going to do the same thing, insert mesh, go into my desktop, and there's my contact switch stock, open it up, and it comes in and I can see it. Again, I can manipulate it. I can move this thing down a little bit. I can see, it compared to the other part. I want to put it right back to where it was. Now, I can move it around, but I'm going to leave it there. I'm going to say OK. And now I have this STL. And again, you can see those facets. You can see the way it's modeled. And you can take the time to go up and make it more of a refined mesh. We don't really have to, but I'm going to use this the way it is. I'm going to just soft click on here. I'm going to call this one my Op2 stock, just so I can see it in the list. It's a good idea to really name these something that makes sense. So whether you're working on it or a colleague's going to work on it or my customer is going to work on it later, he can easily see what those mesh bodies are used for. So, and I can also do this. I can right click. I can change the opacity control. And I can go down and make that something like 40%. So as I highlight it, you can see the original part inside. And as we turn it on and turn it off, you can do a compare, and you can get a good idea of what it looks like inside. Now, one little trick that might help to be able to see this a little bit better is if you go down to our display settings, mesh display, it says face groups. We can do that as well, but I want to go to visual style. And we're just going to turn off this shaded. And now if I turn it on and turn it off, I have a pretty good idea, and I can see closely. If I turn this on and off, I have a good display of before and after. Now, it's not super accurate, but I have, it's STL, but at least I can see really quickly what I have to do on the other side to complete machining this. So it's just a little bit of a tool that you can use to be able to compare what's going on between what was done in the Toolpaths, your result from simulation, and what your original model started with. I'm going to switch it back to visual.
So I'm not shocked that the question came up by multiple people. It's completely unsurprising. A lot of people are saying, why did you have to go through this workflow? Why don't we do it automatically? I agree. It's something that I've personally wanted for 4 or 5 years in the sense that we should be able to automatically store the STL. There is a caveat, though. I did a webinar a few weeks ago on working with large data sets, and the truth is a lot of people use HSM for doing some very, very large molds. So the problem is not solving the workflow. The problem is the size of the data that we could very easily be producing and coming up with a good solution for managing that data and limiting it. But the answer is yes, we would very much like to streamline this workflow. Feels very simple. A little harder than it looks, but it is a high priority. Definitely even more recently with some stuff we're working on. So thanks for bringing it up, Steph and Tom and everybody else. I see Jeff commenting, who leads our development team, and confirming that yes, this is something we're aware of and we want to make more streamlined for everybody.
Yeah, it comes back to those facets again. If you're making an STL, sometimes they let you set a level of accuracy, and more accuracy isn't always better because it means more facets. And if it's a fairly simple part and you have a lot of facets, you're creating a huge data set that you may not need.
Yeah, that's a good point too. And so mainly I'm showing this today just to let you know, I mean, it would be good to have that as an automation tool, and I know we've seen this in the past, working with, I know HSM Works in the past were able to do a more streamlined workflow of this, but I just want to show this that you can do this today. So it's a little bit more of a workflow that you have to do that, but the point is that you're able to use that resulting stock as your or resulting simulation as your stock for the next operation. So
just a couple more clarifications. Sorry to drag on. Honestly, it's no more streamlined in HSM Works. It's just HSM Works is a desktop product, and it just feels weird to take a cloud product and save something to the desktop. So that's the break and streamline there. The other bit is there's a question: is it a solid? And the answer is no. The stock simulation is producing a triangulated model, so as a result, it's definitely a triangulated model. It's not a solid. Wayne might get time or show some resources for how you can help convert it to a solid, but no, it's the result of a simulation is definitely a triangulated model.
Thanks, Al. So let's do that. So I'm going to go back into our CAM, and I made some changes, so I'm going to go in and regenerate that real quick. So I want to be able to flip this model over and use that resultant stock model as the other side so I can see what's going on. So I'm going to copy this. Actually, I'm going to call this one real quick, op1. And I'm going to duplicate this operation just to save a little bit of time as soon as this is done calculating. So what I do is I'm going to right-click, see if it's done there. Good. I'm going to right-click, and I want to go down to duplicate. So I'm going to make a duplicate of the same operation 1, rename this one op2, and now in op2, I'm going to change the stock setup. If I go into the stock view here, I'm going to change this. Instead of being a fixed size cylinder, I'm going to say from solid. I know it says from solid, but I'm going to go into these bodies right here, and I'm going to choose op2 stock, and now it changes to that STL. And if you go back to the setup, you'll see it's now a mesh model. So it's now accepting the mesh now as the stock that we're going to use for the other side. I want to flip this over to the other side, flip it around the Y. So I'm going to go to Z-axis flip, and now we're able to get the part on the other side to be able to machine it. So I put this in my fixture. So real quick, I'm able to make a duplicate, bring in that stock, flip it over, and now we have that mesh body that we're going to use for op2. Now, since I made a duplicate, and I use 3D Toolpaths, I can just right-click on op2, generate Toolpaths. It'll recognize all those features, the same feature, well, the same way it did on op1. It recognizes these features and there's the adaptive clearing, working its way down, the adaptive face. It finds these pockets that we have. I left it up 1/8 of an inch. I can always move that. But it found the other pockets on the other side. The horizontal, looks like it's still working on it, and then our contour is waiting for the result of the horizontal. So I probably will go back in here, and I would come in with a pencil toolpath to clean up in those little corners there where that big tool can't get to. There's our result of the horizontal and our contour. So I would come back in. I would just, while I have this op2, I want to make sure that I have this set as the default folder. I'm going to go into 3D pencil. I'll probably use my 1/8 inch. For my Haas VF2. I use an 1/8 inch ball to get into those little corners and those little nooks there. I'm just going to say okay, because the pencil toolpath, just like the horizontal, is really good at finding its own containment. So it looks at all those places where that tool can go efficiently, and it puts that tool there. Okay, so now our result, op2, we're able to do that really quickly. I was able to get the mesh, or shall I say the STL, to be the stock for the other side. And then we can do a quick simulation on here real quick. We'll play through. So while this is running, are there any other questions that popped up on what I just did?
I see a question about soft jaws. I'm thinking where you're headed with that is wanting to actually create the soft jaws, and that is a little bit more problematic just because it is an STL file, it's not geometry. It doesn't mean you can't do it, you just need to take into account that you're working with an STL file. And again, Wayne, I think you might have had some resources that you could share on how you can help convert that into a solid. But it's not the complete level of accuracy as a parametric solid that was drawn natively in Fusion. So in cases like that, you're better off creating a simplified model of what you're going to machine and having the true geometry.
I would agree. I would agree with that. It's probably better, again, and also as Mike had said, the closer you can get to like the true file or the real geometry that you're looking for, especially when you're doing things like soft jaws, because now you have one body dependent on another body, and that's really where you want to have solids to drive that. Now, one thing we can do, and I'm going to walk through real quick with you one way that we can do make a solid out of this. There's a few different ways, and some of them can be a little clunky, and I'm just a guy who's trying to solve this for machining purposes, but I'm sure there's a lot more people who have more in-depth knowledge of changing these things into solids. But one of the things that's cool about Fusion, and there are other resources, and I just want to show you this right now real quick. We do have some resources I'll first check out Autodesk Knowledge Network. Do a search on Mesh, and you'll see places in here where we have tutorials and walkthroughs on how to be able to make, right, here's a quick tip on Mesh to Solid, adaptations of Mesh modeling, and different ways and different options that you can be able to turn that STL into a solid. So I would first do a search here in our Autodesk Knowledge Network to find a lot of these places where we have quick tips. One thing I'm going to try to walk you through, and I think we can do this pretty quickly, but I'm going to go back into our model workspace. There isn't any kind of direct, create mesh body. You can't really create components because it's just a simple mesh. You can't go to a body. But one thing I'm learning and we're working on is if I go into our create form using our piece line here, we can create a simple primitive model. Like if I did a simple box, right? I just want to show you. Now I probably would do a cylinder and cap off the tops and the bottoms, but just for this demonstration, I'm going to go into box. I'm going to create a rectangle on this bottom plane right here. And I'll start the rectangle in the center, and I'm just going to put a box around this. Now, you probably would do a cylinder or some primitive shape like that. And I have a lot of facets in here, and you can add as many as you need. I'm just going to do right now for 24, just to show simplicity, plus it'll probably take a while for me to do that. So I'm going to create this as a new body. I'm going to say OK. And so I just created this box around my part. My part's in there. So I made this box around it. And one neat thing you can try and work with, and again, this is something that I'm learning, and I think that it will be great for to get more defined and more refined. In this case, if I went to modify and I did pull, and it goes into this pull tool that we can use. So if I put a window around and I select all those vertices, it's looking for T-spline vertices. I can also grab the body too. Okay, and what it does, it references the mesh body, and it tries to pull all those vertices into the mesh body. So what we're doing is we're making that T-spline. We're trying to match up the facets, if you will, of the model. I only use 24, but of course you can get much more refined with your model here. But just to save a little bit of time and be able to show you, this is a quick way that you can pull those P-splines and the surfaces, if you will, onto your mesh body. I say OK, and now we have a body that represents the basic shape. Now again, this is something that you want to play with and get the right amount of vertices and amount of faces you want on there. But this is one option you have to be able to take that geometry, wrap it around your model. It's not really looking pretty here, but if I had enough facets in here, it would work.
It's a great option for working with scan data. If you want to try and make scan data watertight, it'll do a great job of filling in those holes.
Exactly, and that's one way you can do it. But I kept it really simple here, and it would be great to see, this team, this August body here, doing things like this and getting some quick tips out there and helping and finding different ways to make a body. This is one way that I know of. But again, I'm learning too, and as we do go through and find different ways to make solid bodies that we can work with to get better toolpaths, to get more refined, especially when you're scanning data, bringing it in. I know there's a lot of reverse engineering houses doing things like this, but this is just one option that you can work with. Now I would use a simplified model, but you can do that as well. And at the end, you now have this body that you can work with and turn that into a solid and start working with it. So that's one method. And again, I would recommend going to our Autodesk Knowledge Network. I know that our team, like Tim Paul and Marty Deans, have been working with a lot of tools on the CAM side to be able to bring that knowledge to you and how to work with models like this and work with STLs and making solids. And we have our Fusion adoption team who are just amazing at being able to convert models and be able to work with B-splines as well. So there's a large amount of data that you can find and a lot of content that you can be able to find just starting here at our knowledge network on how to learn about P-splines and how to make them solid. So that's one way that I know of, and I'm sure there's other ways, but this hopefully will help you be able to translate that into a solid.
Yeah, this is, Mike, I'd like to say this is a really great collection of tools that you've shown off here, and it really can help you get the job done when you're dealing with a part like this. Now, this is not the kind of part that we're going to stick in a rocket ship. This is the kind of part that's going to go on a little cover on a switch on a 60-year-old golf cart. So, you know, again, the tolerances and the number of points that you select, how accurate this needs to be really isn't that much. You know, you can make it as accurate as you want with the tools that are here, but in a lot of cases for a part like this, simple is good enough.
And I might just add, even on a part like this, another way that you could use it, sometimes people completely forget about, but oftentimes you'll just use the mesh as a canvas to model over top of. So you'll look at that outside thing and maybe you put some calipers on it and know that the outside is a circle that's exactly 3 inches. Some of the other features you've got less certainty over, and you just kind of model your parametric model close to it, but you can certainly use the mesh as a canvas and then create a true solid around it. So I wouldn't go and forget that. A couple other points to questions. Oh, sorry.
Kind of a reverse engineering tool then.
Exactly, and this is just sort of your starting point to model around, and it's going to give you the rough scale and where the features are, and the features that you need more accurately you can measure with calipers or whatever is necessary. So we had a couple of questions pop up. One was somebody working with scan data and working with 2 to 3 million triangles. You are pushing the limits of what Fusion will handle today. I'm told it will handle 500,000 triangles quite well, and then when you're starting to get to 1 million triangles, it'll handle it, but you're going to see some lag. So we've certainly got some work to do to expand the number of triangles. If you're watching this recording in 2 years, that number's probably changed, but that's where it's at live today. We had a question about Inventor, and does Inventor support mesh data? And the answer is yes. The products are at slightly different development schedules, so one might be catching up with the other at certain times, but yeah, these workflows work in Inventor. I'll add that SolidWorks has no support for mesh data, but our HSM Works product is capable of machining on a mesh. The truth is SolidWorks just doesn't know it's there. We kind of float it in the background and let us toolpath the mesh. So I think that's worth mentioning. I also wanted to draw attention, Wayne, if you can go back to CAM, I don't know how many people picked up on it, but a great workflow you used in machining the backside of your part, where he copied and pasted his setup and then just made a couple very small changes to toolpath the whole backside of the part. If you're not doing things like that and reusing the knowledge you've already put into programming, you definitely should be. And it was nice to see you sort of do that and kind of use a real-world toolpathing technique, even though you're focused on mesh. So it was cool.
Yeah, I think it looked like when I was trying to make the form, it's lagging my my Fusion. I think I tried to wrap it around too much, but it looks like it's kind of
not a problem.
Yeah.
Maybe what you could do in closing then, I think there's a lot of resources. A lot of you join these webinars regularly, but a lot of other resources that we have. I know you mentioned Tim and Marty and team working on videos. Recently, Lars Christensen has done some great videos. He just did a really good one on Tool Library. So if you're willing to share a link to that video, I think everybody should at least be well aware of Lars's channel and the stuff Lars is doing. So Lars did a great job talking about how you can use cloud libraries in this video and how you can share them among other users. And also you might see over on the right-hand side, he just finished a 4-part series on designing and machining an injection mold in Fusion. So some other great learning resources.
I just added this link to this video to the chat window in the webinar. So if you guys want to take a look and see a lot of the videos, now Lars is amazing. He does a lot of great videos on how-tos on getting to work, in this case, with your tool libraries. Another one he's worked on is this beginner to advanced, how to create a mold. Really good resource. Check out all the parts of this because he does an amazing job of explaining and simplifying the ways that you can create molds, work with your design, your part, your reverse of the part to be able to make both the cope and die of the mold and be able to machine them both. I mean, he does an amazing job. So I highly recommend check out a lot of Lars's videos, and it's really going to help you out.
So Wayne, what do we have coming up next week?
So next week, I'm hoping that we're able to get more into turning. I'm trying to get together our live tooling webinar on updated webinar on what we do with live tooling, and so I think that'll be a good one for you guys to check out.
You know, the next Fusion update's got some cool turning stuff coming too, so maybe we can even sneak in a little bit of a sneak peek at what's coming down the road for turning if we're focused on turning next week.
That would be awesome. Cool, guys. I don't know if there's any more questions rolling in. Hopefully this has been helpful for you guys to be able to work with STL files. I know there's been a lot of questions on how to get an STL model in here, how to work with it, even editing your STL models. Hopefully this has been helpful. With some tools in here, you could scale, especially if you have the wrong size in here, quickly and easily scale your models, remesh, look at different ways of adding cuts along a plane and working with some of those models to get them ready for you to machine. Also constructing planes, being able to inspect them. So hopefully this has been helpful to see some of these mesh tools in action and how we can use the mesh, the STL, directly inside a CAM to drive your toolpaths. So I'm hoping that this has been helpful for you guys. And as you're working with STLs in the future, yeah, you can always revert back to this. We're going to have it up on our YouTube channel. You can walk through and find more resources on working with STLs. Cool, guys.
Great job. Some people saying Friday last week when all of us at Autodesk were off, it felt weird to not have the webinar. So definitely glad for all of you that join regularly. It's a highlight to my Friday too, just getting a chance to connect with customers on these webinars.
I'd like to say it was a really great topic and a really wonderful presentation, Wayne. Thanks.
Thank you. And thanks, everybody. Thanks for being here with us. And again, next week, we're going to focus more on turning, and I think maybe even over the next couple of weeks as we get more updates, as Al had mentioned, that are going to help our turning users out there. So stay tuned. We're going to keep bringing more content back with you and more topics to help you guys out. So again, thanks for joining us, and stay tuned and check us next week. And just let you know, every Wednesday, if you're new and you're joining us and you haven't really used our interfaces yet and you just started the trial, join us on Wednesdays. We do our walkthroughs, our fast track to CNC, getting that part from your napkin sketch, how to get it into Fusion, and how to get that code, the CAM on there and the code to your machine really quickly. So if you're new, join us on Wednesdays. If you want to learn more about what's up and coming and what our elite users are doing, as well as developers and power users, join us on Friday, and we're going to bring more advanced content to you guys. And don't forget, check out Autodesk University. It's worthwhile to go. So if you can get some time away from cutting those chips, I highly recommend joining us at Autodesk University. So guys, with that, thanks everybody for joining us, and thanks Al and Mike and the whole team for being here to help us answer questions and making this a really good webinar. Thanks, guys.
Wayne, quick question. Can you share a link for the webinars?
The link for our webinars?
The Wednesday webinar. There's a user here that would love to get a link to that.
Oh, absolutely. Yep, I can do that. I have the list of the users who joined. I'll make sure that you guys can get a link. I'll send it out to you guys after the webinar.
Perfect. Thank you, Wayne.
Awesome, guys. Thank you. And we'll see you next week.
See ya.